early December 1942. A forward reconnaissance post, 20 kilometers south of Tobruk, Libya. The morning sun climbed over the desert horizon, casting long shadows across the sandy expanse where a captured American vehicle sat motionless. Its crew had abandoned it during the previous day's engagement, fleeing when British armour appeared on their flank. Standard Wehrmacht procedure dictated destroying captured equipment to prevent its recapture, but Oberfeldwebel Kraus had other plans. He circled the vehicle slowly, his experienced mechanic's eye taking in every detail of its construction. The small identification plate on the dashboard read Willys MB. The Americans called it a Jeep. For 2 decades, Kraus had serviced German military vehicles. He had maintained the sophisticated Kübelwagen with its advanced torsion bar suspension, worked on heavy trucks with their complex running gear, and understood the engineering philosophy that made German vehicles respected throughout the world. But this American machine represented something fundamentally different, something that would challenge everything he believed about proper automotive engineering. The realization wouldn't arrive as a dramatic revelation. It would come slowly, methodically, as he and his team subjected this vehicle to tests that would reveal a design philosophy the Wehrmacht had never fully grasped. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Afrika Korps had been fighting in North Africa since February of 1941. By December of 1942, German forces had encountered American equipment with increasing frequency following Operation Torch, the Allied invasion of French North Africa in November. The desert environment provided the ultimate testing ground for military vehicles. Soft sand could swallow wheels in minutes. Rocky escarpments demanded precise suspension articulation. Temperature extremes, from freezing nights to blistering midday heat, stressed every mechanical component. In these conditions, German engineering had proven itself through the Kübelwagen, Ferdinand Porsche's masterpiece of lightweight design. The Type 82 Kübelwagen represented German automotive thinking at its finest. It weighed just 715 kilograms, making it light enough for 2 soldiers to physically push from soft sand when necessary. Its air-cooled engine eliminated radiator vulnerability to enemy fire and sand infiltration. Its rear-mounted power plant provided excellent weight distribution for desert traction. Most impressively, its independent torsion bar suspension system at all 4 corners delivered a remarkably smooth ride over rough terrain, far superior to the crude leaf springs that characterized most military vehicles. Torsion bar suspension was a relatively recent innovation in automotive engineering. The system used a metal bar attached firmly to the vehicle chassis at one end, with the opposite end connected to a suspension arm. As the wheel moved vertically over terrain, the bar twisted around its axis, providing spring resistance. The advantages were significant. Torsion bars took up minimal space compared to bulky coil or leaf springs. They provided excellent durability with no springs to break or sag. They offered smooth, progressive resistance that absorbed shocks effectively. German engineers considered torsion bar suspension the most sophisticated solution available for military vehicles. The Kübelwagen could navigate terrain that defeated conventional automobiles. Its ground clearance of approximately 29 centimeters allowed it to clear obstacles that would stop lower vehicles. Its flat, smooth underbody let it slide over sand and mud rather than digging in. Its geared reduction hubs at the rear axle provided additional ground clearance while multiplying torque for difficult conditions. If the Kübelwagen had one limitation, German designers knew it well. The vehicle was rear-wheel drive only. In soft sand, on steep inclines, in deep mud, 2-wheel drive meant the Kübelwagen required careful driving technique. Maintain momentum, choose the correct line, avoid sharp turns that might break traction. German drivers learned these skills through experience, developing expertise that compensated for mechanical limitations. The philosophy made sense. Weight saved through simpler drivetrain design could be invested elsewhere. Reduced complexity meant easier maintenance. Fewer parts meant higher reliability. When the Kübelwagen did become stuck, its lightweight meant soldiers could physically extract it without recovery vehicles. This design thinking reflected broader German military doctrine. Equipment should be sophisticated and technically advanced, built to exacting specifications that produced superior performance. Operators should be highly trained specialists who understood their equipment's capabilities and limitations. Success came from the combination of excellent machines and excellent soldiers. The Americans, the Wehrmacht believed, approached warfare differently. American soldiers were less well trained, their equipment was crude, and they relied on overwhelming numbers rather than quality. Intelligence reports had characterized American military vehicles as simple, unsophisticated, adequate for basic tasks, but inferior to German equivalents in almost every meaningful metric. The captured Jeep represented an opportunity to test those assumptions. Kraus called to his assistant, Gefreiter Hans Richter, who approached carrying a basic toolkit. "We need to understand this vehicle completely," Kraus explained. "Not just how it works, but why the Americans designed it this way. Every component tells a story about their thinking." They began with the most visible difference, the suspension system. Where the Kübelwagen used sophisticated torsion bars with intricate mounting points and complex geometry, the Jeep employed the most basic suspension design imaginable. Simple leaf springs at all four corners. Leaf springs were ancient technology, dating back to horse-drawn carriages. Multiple curved metal plates, called leaves, were stacked together and clamped at their center point. The ends were free to flex, providing spring action as the wheel moved over terrain. The design was crude, heavy, and unsophisticated compared to modern alternatives like torsion bars or coil springs. Every German engineering text emphasized moving beyond such primitive technology. Yet here sat an American military vehicle, built in 1942, using what German designers would have considered obsolete engineering from the previous century. Richter ran his hand along the front leaf spring assembly. 8 leaves, he counted. Crude construction. No sophistication at all. Kraus nodded slowly, but his expression was thoughtful rather than dismissive. Measure the spring length and thickness. Document everything. As Richter took measurements, Kraus examined the spring mounting points. The front springs measured approximately 36 inches from mounting point to mounting point. 8 leaves in the front, 9 in the rear, heavy gauge steel throughout. The mounting brackets were simple, welded directly to the frame. Everything was overbuilt, using more material than seemed necessary for a vehicle this size. The spring shackles caught his attention next. These were the pivoting links that connected the springs to the frame, allowing the springs to change length as they flexed. The design was straightforward, using rubber bushings that could be replaced with basic tools. No specialized equipment required. No precision tolerances necessary. A farm mechanic could service this system with a wrench and a hammer. German torsion bar suspension required specialized knowledge to adjust correctly. The bars had to be indexed precisely, with specific torque values applied during installation. Improper installation could cause handling problems or premature failure. Only trained mechanics with factory documentation could properly service the system. The Americans had apparently decided that any soldier with minimal training should be able to maintain their vehicles in the field. Kraus walked to the rear of the vehicle and examined the rear spring assembly. 9 leaves here, slightly longer at 42 inches, designed to support the heavier loads typically carried at the rear. The same simple mounting brackets, the same rubber bushings, the same philosophy of accessibility over sophistication. "Check the ground clearance," he instructed. Richter positioned himself beside the vehicle with a measuring rod. 22 centimeters at the front axle, 23 at the center, 22 at the rear differential. The ground clearance was roughly equivalent to the Kübelwagen, perhaps slightly less, nothing exceptional. But as Kraus studied the overall vehicle geometry, he noticed something interesting about the proportions. The Jeep had a wheelbase of 80 inches, 203 centimeters, shorter than most military vehicles, which typically stretched their wheelbase for stability. But combined with the relatively high ground clearance and short front and rear overhangs, the proportions created favorable angles for terrain negotiation. Approach angle. The maximum slope the vehicle could climb before its front touched the ground appeared steep, perhaps 40 degrees or more. Departure angle at the rear looked similarly favorable. Breakover angle, the ability to crest obstacles without the center scraping, benefited from the short wheelbase. These weren't specifications that appeared in technical manuals. They were practical considerations that determined whether a vehicle could navigate real terrain. The German engineers who designed the Kübelwagen had understood these principles, creating a vehicle with excellent approach and departure angles through its flat underbody and careful weight distribution. But the Jeep's proportions suggested the Americans had also considered these factors, despite their apparently crude suspension design. "Start the engine," Kraus ordered. Richter climbed into the driver's seat and turned the key. The four-cylinder engine fired immediately, settling into a steady idle. The Go Devil engine, as the Americans called it. 134 cubic inches, producing 60 horsepower at 4,000 revolutions per minute. Not impressive by German standards. The Kübelwagen's engine displaced less, but achieved comparable performance through superior engineering efficiency. But as the Jeep idled, Kraus noticed something. The engine ran smoothly, with minimal vibration. The mounting system effectively isolated the body from engine movement. German vehicles sometimes transmitted excessive vibration to the chassis, particularly at idle, a consequence of rigid mounting designed for maximum durability. "Engage four-wheel drive," Kraus said. Richter examined the floor-mounted transfer case lever. A small plate indicated the positions. Two-wheel drive high range, four-wheel drive high range, neutral. Four-wheel drive low range, one lever controlled everything. Richter shifted into four-wheel drive high range. A mechanical chunk indicated engagement. "That simple?" he asked, surprised. "One lever engages all four wheels?" Kraus nodded, impressed despite himself. The Kübelwagen didn't have four-wheel drive at all. German light vehicles relied on rear-wheel drive with clever weight distribution and reduction gearing. Heavier trucks might have all-wheel drive, but even these required multiple steps to engage. The American system was remarkably straightforward. "Drive forward slowly," Kraus instructed. "I want to observe the suspension movement." The Jeep rolled forward across the uneven desert surface. Kraus walked alongside, watching the leaf springs flex and rebound as each wheel encountered irregularities. The suspension movement was visible, obvious, lacking the hidden sophistication of torsion bars. But it worked. Each wheel moved independently, maintaining contact with the ground. The springs absorbed impacts without transmitting harsh shocks to the chassis. The ride appeared controlled, stable, effective. They drove to a nearby area where rocky outcrops interrupted the sand. Kraus directed Richter to traverse the uneven ground at walking speed. The Jeep climbed over rocks that would have required careful navigation in a Kübelwagen. When one wheel lifted over an obstacle, the leaf spring compressed smoothly. When the wheel dropped into a depression, the spring extended fully, keeping the tire in contact with the ground. The suspension's long travel, its ability to compress and extend through a wide range of motion, gave the vehicle remarkable capability over rough terrain. "Stop," Kraus said. He walked to the front of the vehicle and examined how the suspension had articulated. The leaf springs had twisted slightly, allowing the wheels to move in different directions while maintaining their connection to the frame. This flexibility, which would have been impossible with rigid torsion bars, gave the suspension exceptional capability over severely uneven ground. German torsion bar suspension was excellent on moderately rough terrain, providing a comfortable ride and good control. But in extreme conditions, where wheels needed maximum vertical travel and the ability to move independently through large ranges of motion, the simple leaf springs offered advantages that sophisticated torsion bars could not match. "Put it in low range," Kraus ordered. "Find the steepest slope nearby." Richter shifted the transfer case into four-wheel drive low range, multiplying the engine's torque for maximum pulling power at slow speeds. He drove to a rocky escarpment where the slope climbed at approximately 35 degrees. German drivers would have approached such terrain cautiously, building momentum before attempting the climb. Richter simply aimed the Jeep at the slope and steadily applied throttle. All four wheels pulled simultaneously, distributing power to whichever tires had traction. The leaf springs compressed and extended independently as each wheel found purchase on the uneven surface. The short wheelbase meant the front wheels crested obstacles before the rear wheels had to climb, maintaining forward momentum. The engine's modest power delivered steadily through the low-range gearing provided controlled, consistent pulling force. The Jeep climbed the slope steadily, without drama, without requiring momentum or special technique. At the top, Richter stopped and looked back down the slope they'd just climbed. "That would have been difficult in a Kübelwagen," he said quietly. Kraus didn't respond immediately. He was recalculating assumptions he'd held for years. The crude leaf springs, the simple design, the apparent lack of sophistication, none of it represented inferior engineering. It represented different engineering priorities. The Americans had designed for extreme capability over the widest possible range of conditions. They had accepted additional weight, less ride comfort on smooth roads, and simpler technology in exchange for maximum functionality when conditions became severe. More troubling still was what this design philosophy revealed about American thinking. They had built this vehicle expecting it to be operated by soldiers with minimal training, maintained by mechanics with basic tools, used in conditions that would destroy more sophisticated equipment. They had designed for abuse, for misuse, for operation far beyond nominal specifications. They had created a machine that worked reliably when everything else failed. German engineering pursued perfection through sophistication. American engineering pursued reliability through simplicity. In peacetime, the German approach produced superior results. But in total war, under field conditions, by soldiers who weren't automotive specialists, the American approach might prove devastatingly effective. "We need to conduct comprehensive tests," Kraus said. "Document everything. This vehicle needs to go back to Germany for proper analysis." Over the next 3 days, Kraus and his team subjected the captured Jeep to every test they could devise. They drove it through soft sand where Kübelwagen struggled. They loaded it beyond its rated capacity. They traversed terrain that should have been impassable. They operated it continuously without maintenance. The Jeep absorbed everything. In soft sand, where rear-wheel drive vehicles required careful momentum management and often became stuck, the Jeep simply powered through. All four wheels pulled continuously, distributing the load. When one wheel lost traction and spun, power transferred to the other wheels through the differentials. Forward progress continued even when individual wheels struggled. The leaf spring's long travel meant wheels could drop into soft patches and extend fully, maintaining contact and traction even as the terrain varied dramatically. The low-range gearing allowed speeds as slow as marching infantry, roughly 4 kilometers per hour, with full engine power available. This enabled precise control over obstacles, crawling over rocks and through ditches at walking speed with complete control. The Kübelwagen's gearing didn't provide equivalent low-speed capability. Its reduction hubs helped, but the overall range wasn't comparable. Loading tests revealed the Americans' philosophy of overbuilding. The Jeep's rated capacity was 800 pounds of cargo or passengers. The team loaded it with over 1,000 pounds. The leaf springs compressed further, reducing ground clearance somewhat, but the vehicle remained functional. The springs didn't bottom out. The frame didn't flex excessively. The drivetrain handled the additional load without complaint. German vehicles were typically engineered closer to their maximum capacity, using materials efficiently to minimize weight. Exceeding rated capacity risked damage or failure. The Jeep had margins built in, accepting additional weight as the price for robust field reliability. The suspension's simplicity meant field repairs would be straightforward. A broken leaf could be replaced with basic tools. Spring shackle bushings could be swapped by anyone with minimal mechanical knowledge. Everything was accessible, visible, obvious. No hidden complexity. No special procedures. The Americans had designed this vehicle, expecting that farm boys and factory workers, given basic training, would need to maintain it under combat conditions thousands of kilometers from proper facilities. Word spread through the Afrika Korps units in the sector. Officers and mechanics from other companies arrived to examine the American vehicle. The reactions followed a predictable pattern. Initial dismissal of the crude suspension, surprise at the capability, grudging respect. Then, concern as the implications became clear. One supply officer who had worked in German automotive plants before the war spent an afternoon examining the Jeep. His assessment was blunt and troubling. "This suspension represents a fundamental philosophical difference," he explained to the assembled officers and NCOs. "We build vehicles to achieve engineering perfection. The Americans build them for soldiers to use. In peacetime production, our approach produces superior results. In total war, their approach may prove more effective." He pointed to the leaf springs. "These are primitive, yes, but they're producible. Any metalworking shop can stamp these leaves. Any factory that makes truck parts can build this suspension. No special machinery required, no precision tolerances necessary. Training times for assembly workers are minimal. Production rates can be extremely high." He walked to the transfer case, pointing at the simple four-wheel drive engagement mechanism. "This system gives every driver four-wheel drive with one lever. No special training required, no complex procedures. Any soldier can engage it immediately when needed. Our Kübelwagen saves weight through rear-wheel drive, yes, but in difficult terrain, that limitation requires skilled driving to overcome." The assembled German soldiers fell silent. He had articulated what many were beginning to suspect. German vehicles were better engineered in the traditional sense, superior in specifications and sophistication. But American vehicles were better designed for the realities of modern mechanized warfare, fought by mass armies across global theaters. One mechanic, who had been with the Afrika Korps since its arrival in North Africa, asked the question everyone was thinking. How many of these can they produce? The supply officer's response sent a chill through the group. Intelligence estimates suggest American factories are producing military vehicles at rates of thousands per day. They've converted their entire automotive industry to military production. Every truck factory, every car plant, all building to standardized designs with interchangeable parts. We cannot match that capacity, not even approximately. Germany had mobilized its economy for total war, stripping civilian production to support military manufacturing. Yet German vehicle production remained limited by industrial capacity, materials availability, and the complexity of the designs being built. The Kübelwagen, despite its excellence, required skilled labor and specialized components. Production ran to tens of thousands per year. The Americans were apparently producing comparable vehicles at rates 10 times higher, while also building thousands of trucks, tanks, and aircraft simultaneously. The captured Jeep sat in the desert sun, looking unremarkable, just another military vehicle among thousands scattered across North Africa. But to the Wehrmacht mechanics who had examined it thoroughly, it represented something profoundly troubling. Evidence that American industrial capacity and design philosophy had created a combination that Germany could not counter through superior engineering alone. Quality could not overcome quantity when the quantity arrived in this volume, and the quality gap was narrower than German propaganda suggested. Kraus spent that evening writing a detailed technical report. He documented every aspect of the Jeep's design, noting both its strengths and limitations. The suspension was crude but extraordinarily capable. The four-wheel drive system was simple but remarkably effective. The overall vehicle lacked sophistication but excelled at its intended mission. His report made its way up the chain of command, eventually reaching Wehrmacht headquarters in Berlin. Similar reports were arriving from every front where German forces encountered American equipment. The pattern was consistent and troubling. American vehicles weren't as well engineered as German equivalents in traditional metrics, but they were better designed for mass production, easier to maintain, simpler to operate, and often more effective under actual field conditions. The crude leaf spring suspension on the Jeep embodied this entire philosophy. less sophisticated than German torsion bars, certainly, but more capable over extreme terrain, easier to produce in massive quantities, simpler to maintain in the field, and more forgiving of operator error or abuse. In total war, those factors mattered more than engineering elegance. December 19, 1942. The captured Jeep was loaded onto a transport truck bound for the port at Tripoli. From there, it would travel by ship to Italy, then by rail to Germany. Wehrmacht Technical Intelligence Services wanted to conduct comprehensive testing at proper facilities. They needed to understand exactly what the Americans had created and what it meant for Germany's prospects in a war that was consuming resources faster than they could be replenished. As the transport truck pulled away, Kraus watched the Jeep disappear into the distance. He had spent his career believing that German engineering was the finest in the world. That belief wasn't wrong, exactly. German engineers possessed extraordinary knowledge and skill, but the Americans had asked different questions, pursued different goals, and created solutions that might prove more effective in the brutal arithmetic of industrial warfare. The crude leaf springs that had initially seemed like evidence of American inferiority now looked like evidence of American pragmatism. And that pragmatism, multiplied by industrial capacity that dwarfed Germany's, represented a challenge that superior engineering alone could not overcome. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Spring of 1943. Kummersdorf Proving Ground, Brandenburg, Germany. 25 kilometers south of Berlin, the Wehrmacht's primary testing facility occupied 878 hectares of former Prussian forest land. Here, meticulous engineers measured, tested, and analyzed everything from artillery shells to tank armor. The captured Jeep, designated Kübelwagen 259 and assigned German license plate WH058941, rolled off the transport rail car on a cold March morning. Test engineers had already stenciled armor thickness measurements and technical notations across its surface, marking it for comprehensive evaluation. Kummersdorf had tested captured Allied equipment before: British trucks, Soviet tanks, French armored cars. Each vehicle underwent exhaustive examination, their strengths and weaknesses documented in detailed reports that circulated through Wehrmacht technical branches. But this American vehicle had generated unusual interest from senior officers. Reports from North Africa, Italy, and the Eastern Front all described the Jeep's remarkable off-road capability. Intelligence wanted to understand why a vehicle with such primitive suspension could perform so effectively. The testing program began with basic documentation. Engineers photographed every component from multiple angles. They measured suspension geometry with precision instruments. They recorded spring rates, shock absorber characteristics, and wheel travel distances. Everything was documented to scientific standards, creating a permanent record of American design choices. The suspension system received particular attention. Each leaf spring was removed, measured, and analyzed. The front springs consisted of 8 leaves, measuring 36¼ inches from mounting eye to mounting eye. The rear springs had 9 leaves, 42 inches long. The steel was high quality but not exceptional. The manufacturing was competent but not precise by German standards. What struck the engineers was the suspension's travel distance. German vehicles typically had suspension travel of perhaps 6 to 8 inches. The distance wheels could move vertically from full compression to full extension. The Jeep's leaf springs allowed nearly 12 inches of travel. This meant wheels could drop into depressions or rise over obstacles through a much greater range while maintaining tire contact with the ground. The simple leaf springs, because they were long and relatively thin, could flex through extreme ranges that more sophisticated suspension systems couldn't match. A senior suspension engineer, Dr. Friedrich Hartmann, explained the implications to his colleagues. Torsion bar suspension provides excellent ride comfort and takes up minimal space, It's sophisticated, efficient, elegant. But torsion bars are fundamentally limited in how much they can twist before reaching their elastic limit. The Americans have chosen a different compromise. These crude leaf springs sacrifice ride comfort and take up more space, but they provide exceptional wheel travel. In severe off-road conditions, that travel distance becomes more important than sophistication. The testing moved to controlled trials on Kummersdorf's obstacle courses. Engineers drove the Jeep through courses designed to evaluate suspension capability, measuring performance against known standards. The first course tested articulation, the ability of wheels to move independently while maintaining traction. Deep ruts forced diagonal wheels to compress and extend simultaneously, twisting the chassis. German vehicles typically handled moderate articulation well. The Jeep simply drove through obstacles that would have required careful technique in most Wehrmacht vehicles. As the right front wheel dropped into a deep rut while the left rear climbed over a rock, the leaf springs twisted and flexed, allowing both wheels to maintain contact with the ground. The spring's length meant they could bend without bottoming out or losing compliance. The simple shackle mounts meant the springs could change their effective length as needed, accommodating the twisting motion. The Kübelwagen's independent torsion bar suspension, theoretically, should have handled this better. Independent suspension meant each wheel could move separately without affecting others. But the torsion bar's limited travel meant they ran out of movement before achieving the same articulation the Jeep's leaf springs provided. The hill climbing trials demonstrated another advantage of the leaf spring design. Engineers constructed slopes of varying angles, measuring the maximum gradient each vehicle could climb. The Jeep's approach angle, the steepest slope it could engage without the front bumper striking the ground, measured 45 degrees. Departure angle at the rear was 35 degrees. Breakover angle, the ability to crest obstacles without the center scraping, was 25 degrees. These numbers weren't exceptional by theoretical standards, but combined with the four-wheel drive and long suspension travel, they produced remarkable real-world capability. German test drivers who had experience with both Kübelwagens and the Jeep noted the difference in technique required. The Kübelwagen demanded skilled driving to maximize its capabilities, choose the correct line, maintain momentum, use terrain features to advantage. The Jeep simply required pointing it at the obstacle and applying throttle. Four-wheel drive meant power went to all wheels continuously. Long suspension travel meant wheels maintained contact even over severely uneven ground. The low-range gearing provided controlled power delivery at walking speed. One test driver, Feldwebel Otto Schmidt, had operated vehicles in North Africa before transferring to the testing facility. His assessment was brutally honest. The Kübelwagen is a better vehicle on roads and moderate terrain, more comfortable, more efficient, better engineered. But when terrain becomes severe, the Jeep is simply more capable. Any driver can operate it effectively, no special skill required. That simplicity is devastating when multiplied across thousands of vehicles. The cross-country endurance trials revealed another aspect of the American design philosophy. Engineers drove the Jeep across Kummersdorf's rough terrain courses for hundreds of kilometers, monitoring component wear and stress. The leaf springs absorbed tremendous punishment without failing. Individual leaves might crack under extreme stress, but the multi-leaf design meant the spring pack continued functioning even with damage. A broken leaf was an inconvenience, not a mission-ending failure. German torsion bar suspension, when pushed beyond its limits, could fail catastrophically. A broken torsion bar meant the affected wheel lost all suspension, making the vehicle difficult or impossible to control. The bar would need complete replacement, requiring specialized tools and procedures. The Jeep's leaf springs could be repaired in the field with basic equipment. A broken leaf could be removed and the vehicle could continue operating with reduced capacity. Or a replacement leaf could be installed using simple hand tools. The Americans had designed for field maintainability in ways German engineers had never prioritized. The testing also evaluated the Jeep's performance in different terrain conditions. Soft sand courses replicated North African conditions. Deep mud simulated Russian spring thaws. Rocky sections tested suspension durability. In every environment, the combination of four-wheel drive and long-travel leaf springs produced consistent capability. The vehicle wasn't perfect. In soft sand, the Jeep's weight of 2,450 pounds worked against it compared to the Kübelwagen's 715 kilogram mass. The heavier vehicle sank deeper, requiring more power to maintain momentum. But the four-wheel drive compensated, providing traction that rear-wheel drive couldn't match. In deep mud, the leaf spring's exposure became a liability. Mud collected in the spring pack, adding weight and potentially reducing flexibility. But the simple design meant the springs could be cleaned easily, and even when packed with mud, they continued functioning. Sophisticated torsion bars, if damaged by mud or debris entering their sealed housing, would require complete disassembly to repair. In rocky terrain, the leaf springs absorbed impacts that would have damaged more delicate components. The springs could bend, flex, and twist without permanent damage. The overbuilt construction meant margins existed for abuse. German engineering typically calculated strength requirements precisely, minimizing excess material to save weight. The Americans had apparently decided that overbuilding components was preferable to field failures. By late spring of 1943, Kummersdorf had accumulated extensive data on the Jeep's suspension performance. The engineers prepared comprehensive reports documenting their findings. The conclusions were technically precise but strategically troubling. The leaf spring suspension was indeed crude by German engineering standards. It was heavy, unsophisticated, and inefficient compared to modern alternatives. But it was also extraordinarily capable, easily maintainable, and virtually indestructible under field conditions. More importantly, it was producible in massive quantities using relatively unskilled labor in factories that previously made civilian vehicles. Dr. Hartmann's final report included a section comparing German and American design philosophies. German automotive engineering pursues optimal efficiency through sophisticated solutions. We minimize weight through careful calculation. We achieve superior ride comfort through advanced suspension design. We create vehicles that perform excellently when operated by trained personnel under proper conditions. American automotive engineering pursues robust functionality through simple solutions. They accept additional weight as the price for durability. They achieve exceptional capability through basic but effective design. They create vehicles that perform adequately under the worst conditions when operated by minimally trained personnel. The report concluded with an observation that Wehrmacht leadership found uncomfortable. In peacetime conditions, German engineering philosophy produces superior results. In total war conditions, American engineering philosophy may prove more effective. The difference lies not in technical knowledge but in design priorities. We build for excellence. They build for war. The captured Jeep remained at Kummersdorf through 1943 and into 1944, available for comparative testing whenever new German vehicles or captured Allied equipment arrived. It became something of a benchmark, the standard against which other light vehicles were measured. When new Kübelwagen variants appeared, they were tested against the Jeep. The German vehicle always won on paved roads, in fuel efficiency, in ride comfort on moderate terrain. The Jeep always won in severe off-road conditions, in ease of operation, in field maintainability. The pattern was consistent and undeniable. Additional captured Jeeps arrived at Kummersdorf throughout 1944. Some had been taken from British units in Italy, others from Soviet forces on the Eastern Front. The Soviets had received over 4,000 diesel-powered M4A2 variants through Lend-Lease. Every captured example underwent similar testing, building a comprehensive database of American vehicle capabilities. The consistency across variants impressed the German engineers. A Jeep built by Willys in early 1942 performed identically to one built by Ford in late 1943. The parts were completely interchangeable. A leaf spring from one vehicle fit any other without modification. The Americans had achieved true standardization, something German industry struggled with despite years of effort. Manufacturers building the same vehicle in Germany often introduced subtle variations that prevented complete parts interchangeability. Reich Minister Albert Speer, responsible for German armaments production, visited Kummersdorf in June of 1943. The demonstration program included comparative trials of German and American vehicles. Speer watched as a Kübelwagen and the Jeep attempted the same obstacle course. The Kübelwagen completed the course but required skilled driving and careful technique. The Jeep simply powered through, demonstrating the capability that had made it beloved by Allied troops in every theatre. After the demonstration, Speer asked pointed questions. Can we produce a vehicle with similar capability? The chief engineer's response was carefully diplomatic. We could design such a vehicle, but it would require four-wheel drive, which adds weight and complexity. It would need robust suspension with long travel distance. It would be heavier and less fuel-efficient than the Kübelwagen. And it would take 18 months to 2 years to design, test, and begin production. Speer understood the implications. By the time Germany could design and produce a competing vehicle, the war would likely be decided. The Americans and British already had hundreds of thousands of Jeeps in service. Trying to catch up was futile. The testing facility prepared additional reports through late 1943 and early 1944. These documents circulated through Wehrmacht technical branches, reaching senior officers responsible for equipment procurement and doctrine. The reports confirmed what field commanders had been reporting for months. American vehicles were reliable, capable, and produced in quantities Germany couldn't approach. The Jeep's suspension became a symbol of this disparity. Simple technology that German engineers initially dismissed had proven devastatingly effective when deployed at massive scale. Field reports from German units using captured Jeeps reinforced the testing data. Wehrmacht mechanized units, desperate for reliable vehicles as their own equipment degraded under sustained combat, eagerly employed any captured American vehicles they could obtain intact. German soldiers who experienced both vehicles expressed clear preferences. For road travel and normal conditions, the Kübelwagen was superior, more comfortable, more economical, more refined. For combat operations in difficult terrain, the Jeep was preferred, more capable, more reliable, simpler to maintain. The psychological impact of this preference troubled Wehrmacht leadership. German soldiers were supposed to have confidence in German equipment superiority. Discovering that captured enemy vehicles outperformed German equivalents under combat conditions damaged morale and reinforced growing doubts about Germany's ability to win the war. One Oberst, who commanded a reconnaissance battalion in Italy, wrote in his after-action report, after capturing several Jeeps during the fighting at Anzio, "My men prefer the American vehicles for patrol operations. The four-wheel drive and robust suspension provide capability our Kübelwagens cannot match in mountain terrain. This preference disturbs me deeply, as it suggests our equipment development has failed to prioritize the correct characteristics." By early 1944, the pattern had become impossible to ignore. Germany had better trained soldiers, superior tactical doctrine in many areas, and sophisticated equipment designed to exacting standards. But the Allies had overwhelming industrial capacity, producing simpler equipment that worked reliably under the worst conditions. In a war of attrition, reliability and quantity mattered more than sophistication and quality. The Jeep's primitive leaf springs, initially viewed as evidence of American engineering inferiority, had become evidence of American industrial might and pragmatic design thinking. The testing at Kummersdorf continued through 1944, as additional captured vehicles arrived and new German designs were evaluated. But the fundamental conclusions never changed. The Americans had created a vehicle that any soldier could drive effectively, any mechanic could maintain with basic tools, and any factory could produce in massive quantities. The Germans had created vehicles that required skilled operators, specialized maintenance, and sophisticated manufacturing. In peacetime, the German approach was superior. In total war, the American approach was devastating. One test engineer, Hauptmann Klaus Weber, who had spent 2 years evaluating captured Allied equipment, summarized the situation in a private letter to his brother serving on the Eastern Front. "We have been asking the wrong questions. We asked how to make the best vehicle. The Americans asked how to make enough good vehicles. We optimized for perfection. They optimized for production. Our vehicles are better individually. Their vehicles are better collectively. In a long war, collective capability decides outcomes." The captured Jeep that had arrived at Kummersdorf in March of 1943 remained at the facility through the end of 1944. It had been driven thousands of kilometers over the most punishing terrain German engineers could devise. The leaf springs still functioned. The four-wheel drive system still engaged smoothly. The simple, crude, unsophisticated suspension continued working reliably, day after day, test after test. German torsion bar suspension was more advanced technically, but the American leaf springs were more advanced practically. They represented design thinking that prioritized function over form, reliability over refinement, producibility over perfection. By late 1944, as Allied forces advanced from both east and west, the testing program at Kummersdorf began winding down. Critical resources were needed for weapons production, not evaluation of enemy equipment whose superiority had already been documented extensively. The engineers who had spent months testing the Jeep understood that they had witnessed a fundamental shift in automotive engineering philosophy. The future belonged to designs that could be mass-produced and maintained by ordinary people, not masterpieces that required specialists to build and operate. January of 1945 brought the final admission of German automotive failure. A meeting of the Panzer Commission produced a report documenting catastrophic mechanical failures across all German vehicle types. The Wehrmacht's sophisticated designs, built to demanding specifications by skilled craftsmen, were failing in the field at rates that made sustained operations impossible. Vehicles broke down faster than they could be repaired. Spare parts couldn't be produced in sufficient quantities. The entire system was collapsing under the strain of total war. Meanwhile, Allied forces continued advancing with fleets of simple, reliable vehicles that just kept working. The Jeep had become ubiquitous across every front. German soldiers who encountered American units reported hundreds of identical vehicles, all functioning, all capable, all supported by supply chains that delivered parts and fuel without interruption. The contrast with Wehrmacht logistics, where every unit struggled with different vehicle types requiring unique parts and maintenance procedures, was stark and demoralizing. The testing facility at Kummersdorf prepared for evacuation in early 1945 as Soviet forces advanced relentlessly toward Berlin. Engineers frantically packed testing data and shipped documentation to facilities farther west, hoping to preserve technical intelligence for whatever came after the war. Some of the captured vehicles, including 2 Jeeps, were pressed into improvised service with combat units desperately defending the approaches to Berlin. The irony was bitter. German forces, fighting to defend their capital, relied on captured American vehicles because their own equipment had failed. The final battle report from the improvised unit noted that the Jeeps continued operating until destroyed by enemy fire or abandoned when fuel supplies ran out. The German vehicles, including the few remaining Panthers and Tigers, broke down from mechanical failures at rates that shocked even experienced crews accustomed to poor reliability. The sophisticated German designs couldn't survive the strain of continuous combat operations. The simple American designs kept functioning until physically destroyed. The story of Wehrmacht mechanics and the Jeep suspension represents one of the great industrial lessons of World War II. German engineers, working within a system that prioritized technical sophistication and precision manufacturing, produced vehicles that looked impressive on paper but failed in sustained field use. American engineers, working within a system that prioritized mass production and field reliability, produced vehicles that seemed crude but excelled under the worst conditions. Neither approach was inherently superior. The question was, which philosophy better served the needs of total war fought by mass armies across global theaters? The leaf spring suspension, dismissed initially as primitive and unsophisticated, had proven devastatingly effective when combined with four-wheel drive and deployed at massive scale. The simple technology could be produced by semi-skilled workers in factories that previously made civilian vehicles. It could be maintained by soldiers with minimal training using basic tools. It provided exceptional capability over terrain that defeated more sophisticated alternatives. These characteristics, multiplied across hundreds of thousands of vehicles, created military capability that Germany couldn't counter. The German surrender in May of 1945 ended the testing program at Kummersdorf. Soviet forces occupied the facility, capturing the remaining equipment and documentation. The jeeps that had been tested so extensively became property of the Red Army, which used them alongside the thousands received through Lend-Lease. The knowledge gained through testing, the understanding of American design philosophy, the recognition that simplicity could defeat sophistication when combined with industrial might, all of this survived in the minds of German engineers who would rebuild their nation. In the decades following the war, West German automotive manufacturers adopted a hybrid approach that synthesized German precision with American mass production philosophy. Companies like Volkswagen, which had produced the Kübelwagen during the war, evolved into global automotive giants by combining German engineering quality with American production efficiency. The result was vehicles that balanced sophistication with reliability, technical excellence with manufacturability. The Volkswagen Beetle, which became one of history's best-selling automobiles, embodied this synthesis. It was simple, reliable, producible in huge quantities, and affordable for average families. Former Wehrmacht mechanics who had maintained captured jeeps during the war recognized the design philosophy. Robust functionality through simple solutions, acceptance of additional weight for durability, design for ease of production and maintenance. Mercedes-Benz, BMW, and other German manufacturers followed similar paths. They retained German attention to quality and engineering excellence, but adopted American production methods and design for manufacturing principles. The synthesis created an automotive industry that dominated global markets for decades, building vehicles that combined the best aspects of both philosophies. The economic miracle of the 1950s and 60s owed much to these changes. West Germany became an export powerhouse, selling vehicles globally that neither pre-war German nor American approaches could have produced alone. The leaf spring suspension gradually disappeared from passenger vehicles as independent suspension systems improved and became more affordable to manufacture. But the lessons learned from comparing German torsion bars to American leaf springs remained relevant. Sophisticated technology isn't always better technology. Simple solutions that work reliably under all conditions often prove more effective than advanced solutions that only work under optimal conditions. Design for manufacturing matters as much as design for performance. These principles influenced not just automotive engineering but manufacturing philosophy across all industries. By the 1970s, the Jeep itself had evolved significantly from its World War II origins. The United States Army began replacing it with the HMMWV, a more sophisticated vehicle designed for modern warfare's different demands. But the original Jeep's influence extended far beyond its military service. It had pioneered the sport utility vehicle category, inspired countless imitators worldwide, and demonstrated that rugged capability could appeal to civilian buyers. Every SUV, every off-road vehicle, every four-wheel drive system in modern automobiles owed something to the design thinking embodied in those simple leaf springs. The final Afrika Korps reunion took place in 1998. Fewer than 24 veterans attended, all in their 70s or 80s. Survivors of a conflict that had ended more than half a century earlier. Someone mentioned that a local museum had acquired a restored Willys MB Jeep most wanted to visit. They stood around the vehicle, these elderly men who had once been young soldiers in Africa, examining it with eyes that still remembered technical details from decades past. One veteran reached out to touch the leaf spring, his arthritic fingers tracing the familiar curves. "I tested one of these in '42, he said quietly. "Thought the suspension was crude. Took me weeks to understand that simple was actually sophisticated. They built it right for what they needed. Another nodded. The torsion bars on our Kübelwagen were more advanced. Better engineering by traditional standards, but these leaf springs worked better where it mattered. Took me years to accept that. A third veteran added softly, "We built for perfection. They built for war. We lost because we asked the wrong questions." They stood in silence for a moment, the jeep sitting before them, a museum piece now, its war long over. But for these veterans, it represented something more than a historical artifact. It was evidence of the design philosophy that had defeated them, the industrial capacity that had overwhelmed their technical sophistication, the pragmatic thinking that had proven more effective than their pursuit of engineering excellence. "We never had the right priorities," one finally said. "We built vehicles for engineers to admire. They built vehicles for soldiers to use. In war, that difference was decisive." This was the lesson that Wehrmacht mechanics had learned examining captured jeeps in the deserts of North Africa, in the forests of Kummersdorf, in the ruins of Berlin. Pride had told them that sophisticated engineering was superior, that quality would triumph over quantity, that advanced technology would overcome simple solutions. Reality taught them otherwise. The crude leaf springs that had initially seemed like evidence of American inferiority had proven to be evidence of American wisdom. Simple, robust, effective technology, mass-produced and deployed at overwhelming scale, had been more decisive than any amount of sophisticated engineering built in limited quantities. The defeat taught humility. The captured American equipment taught practical engineering. The combination produced a new German philosophy that served the nation far better than pre-war arrogance. The mechanics who admitted they had never understood the true genius of simple design became architects of renewal. Their willingness to learn from defeat, to recognize that different didn't mean inferior, to accept that sometimes the best solution was the simplest one, all of this wisdom helped rebuild a nation from ruins. The story of Wehrmacht mechanics and the Jeep's suspension is ultimately a story about learning through defeat. It's about recognizing that assumptions can be wrong, that sophistication isn't always superior, that sometimes the most effective solution is the one that works reliably when everything else fails. The leaf springs that German engineers initially dismissed as primitive had been precisely what the situation required. And the willingness to acknowledge that truth, painful as it was, became the foundation for Germany's remarkable post-war success. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.